And to write an equation for this relationship, well, I kind of want a starting position. I want to get back to 0. So how do I get back to 0? Well, I can get back to 0, and maybe I'm just going to go up a little bit so I can have room to write. If I go back to 0, I can subtract 20 shirts. But if I subtract 20 shirts, how much money would I have to subtract? I'd have to subtract $159. So for 0 shirts, it looks like I would be charged $40. And that then represents the starting position of my graph. Okay, that starting position is going to be, I start at $40. Now, having a starting position and I understand how it changes, I can write an equation. So my y is equal to, well, I'm going to multiply by this rate of $7.95 per shirt. And I'm going to times the number of shirts. And it started at $40. So $40 is my initial charge. That may be, a setup charge or something like that, some fee that I have to pay. And then for each shirt, I'm getting charged $7.95. So this is how I'm going to describe these linear relationships. I have this rate or slope, and I have this starting point. And that describes, remember those two things that describe a straight line, the slope and a starting position. And if we can figure out what those things are and relate it to the equations, we can come up with an equation that looks like this. So this is my equation. Writing it in function notation, I get f of x is equal to, if I input my number of shirts, okay, I'm going to get an output of my charge. And there's what my graph is going to look like. So I want to know, what is the charge for 130 shirts then? Well, now I have an equation. Okay, so this is my charge is equal to $7.95 per shirt times the number of shirts plus the original charge of $40. Okay, so using that calculation, then I'm going to figure out the charge for 130 shirts. So I start with my $40 plus 130 shirts times $7.95 each, and I'm going to end up with $1,073.50. There is my charge for 130 shirts. And that would be about right if I looked at my graph. It's going to be somewhere up in there. How many t-shirts could $938.35 buy? Well, I have the charge in this case. So now I have the charge, 938.35, okay, and that's going to be equal to 795 times x plus 40. So I can undo this calculation to figure out the number of t-shirts. So subtracting 40 from both sides, and I need to get rid of this times $7.95 by dividing by $7.95, and that would give me the number of shirts involved here. So the number of shirts, 898.35 divided by 7.95 gives me 113 shirts, which is about what I would expect. Okay. And then lastly, what's the charge for 0 shirts? If I have 0 shirts, we've kind of figured that out because that was an important point to have. With 0 shirts, I figured out by using that ratio of change and going backwards on the table, I found that I started off with 0 shirts and $40. So charge for 0 shirts then must be $40. Okay, and we could also do that by just plugging into our 0 for x, using making a table of values for all these. And again, since I've calculated a whole bunch of points, I'm going to just summarize my table of values here. I've got my table of values there, and I've added on a few more points into that table of values. So 0 and 40, okay, I had 130 shirts, 1073.50. Okay, I have 113 shirts, and that was $938.35.